need to strip away unnecessary metadata from your AI tools while keeping the core functionality intact. You'll see how to create a clean, simplified version of an existing tool by removing all meta information in just one line. This pattern is perfect when you want to declutter tools for specific use cases or prevent metadata from influencing tool selection.
Hash remove meta information from parent tool. Simplified tool equals tool from tool. Analyze data. Name equals simple analyzer. Meta equals none hash removes any meta information.
This demonstrates the tool transformation pattern, a declarative approach to adapting existing tools without modifying their core implementation. The pattern creates specialized variants of tools by wrapping them with new metadata, argument schemas, or behavior modifications. What makes this distinctive is its ability to separate interface concerns from implementation, letting you tailor tools for specific contexts while reusing the underlying logic. The transformation works by composing layers of configuration around the original tool. You define changes to names, descriptions, argument handling, or even complete behavior overrides, while the framework manages the delegation to the parent tool. This follows the decorator principle, where each transformation is a self-contained modification that doesn't alter the original tool's code or other transformations. This approach solves the problem of tool proliferation and interface mismatch in modular systems. Instead of creating similar tools from scratch or maintaining parallel implementations, you adapt existing tools to new requirements. It's particularly valuable when integrating third-party tools, exposing client libraries as tools, or creating domain-specific variants of generic utilities. The trade-off is a slight indirection cost, but the reduction in code duplication and improved maintainability typically outweighs this. Let's break it down line by line.
Hash remove meta information from parent tool. Simplified tool equals tool from tool.
This creates a new tool by cloning an existing one. The from tool class method is the factory pattern for tool duplication, preserving core functionality while allowing selective modifications.
Analyze data.
This is the original tool function being wrapped. Analyze data contains the core logic we want to reuse, but with modified metadata in the new simplified tool instance.
Name equals simple analyzer.
This assigns a new name to the tool, overriding the original function name. Critical for tool identification in AI workflows, as the name determines how models reference and call the tool.
Meta equals none hash removes any meta information.
This explicitly removes all metadata from the tool. Metadata often includes descriptions, tags, or other non-functional attributes that aren't needed for basic operation. So setting meta equals none creates a minimal tool instance with only core functionality. Closes the tool from tool constructor call, finalizing the creation of a simplified tool instance with stripped metadata. This pattern ensures clean tool definitions by explicitly removing unnecessary attributes that could interfere with serialization or usage. Tool transformation pattern. The tool from tool method enables dynamic tool behavior modification by stripping metadata, renaming tools, and even replacing execution logic entirely through transform functions. Setting meta equals none completely removes static metadata while preserving runtime execution capabilities, creating a tool that's both simpler and more flexible. This pattern lets you expose existing Python clients as MCP tools without boilerplate, treating tool definitions as malleable interfaces rather than fixed implementations.
The tool that forgets its name remembers every purpose